right, buckle up, everybody, because today we're diving headfirst into a mystery. We're talking about the Riemann hypothesis.
Yeah, it's a real brain twister.
It's one of those mathematical enigmas that's baffled the greatest minds for, over a century. We're talking about prime numbers here. We've got this video lined up, plus some notes on it all.
And rather than getting bogged down by equations, which we can all agree is kind of intimidating,
Oh, yeah, absolutely.
we're going to break it down. We're going to look at the story, the big names in the field,
Yeah.
and try to answer the big why. Why is this hypothesis such a big deal? Because honestly, it can change everything from cybersecurity to, how we understand physics.
Prime numbers, right. Sounds simple enough. We all learned about them back in school. 2, 3, 5, 7, 11. Those numbers you can only divide by 1 in themselves.
The building blocks of all the other whole numbers, really. Except their arrangement, the way they show up on the number line, it's like
they're scattered randomly. There's no obvious pattern.
precisely. And that's the allure of the Riemann hypothesis. It suggests there might be a pattern hiding in that seeming chaos. This isn't just some theoretical head-scratcher. Understanding prime numbers is crucial, like really crucial for things like cryptography.
Yeah, like keeping our online transactions safe, right?
Exactly. So if we crack the code of prime numbers, who knows what doors that might open in cybersecurity? It could be revolutionary.
So where do we even begin with this whole Riemann hypothesis thing? Where does it all start?
Well, we start with a hunch. Carl Friedrich Gauss, he was a bit of a legend, real giant in the world of mathematics. He sensed it, this link between how often we find those prime numbers and this thing called the logarithmic integral.
Hold on, back up. Logarithmic. Okay, sorry, go on.
It's okay. Think of it like this. Gauss found a piece of a Traeger map, right? Like a clue that hints at some deeper connection.
So we've got prime numbers scattered all over the place, and Gauss, he finds a clue that maybe, just maybe, there's a pattern to their randomness. What next?
Well, then comes Leonhard Euler, another giant of mathematics, right? He had this amazing tool he created, the Zeta function. Now, this function, it's kind of like a mathematical chameleon. It can represent these complicated series of numbers in a really elegant way. And what Euler discovered was that his Zeta function, when fed the right input, could actually give us information about prime numbers.
Okay, so we've gone from a hunch about a hidden pattern to a potential tool to understand it. This is where Riemann comes in, right?
Exactly. Bernhard Riemann, a brilliant mathematician, took Euler's Zeta function and thought, hey, what if we take this for a spin in a different dimension? Literally. He started looking at it in the world of complex numbers. Imagine like stepping off a flat map and into a 3D world. That's what Riemann did.
Okay, so we need a visual here. Picture a number line, but instead of just going left and right, it also goes up and down, like a whole grid, a plane of numbers. And scattered across this plane are these special points.
Riemann called them non-trivial zeros. And he proposed something really bold. He said that these zeros weren't just scattered randomly. They all lined up perfectly on a straight line right down the middle of this plane. This line, we now call it the critical line. That's the core of the Riemann hypothesis.
So it's like finding a perfectly straight fence in the middle of this crazy multidimensional field. And if it's true, it could unlock so much about how we understand prime numbers. But the question is, has anyone actually been able to prove it?
That's the million-dollar question, isn't it?
Yeah.
And it's been haunting mathematicians for over 150 years. It's a kind of locked box that we know has a solution. We just haven't found the key to open it yet.
Even though it remains unproven, just trying to figure it out has pushed the limits of mathematics, hasn't it?
100%. Just imagine the space race, right? Even if we hadn't made it to the moon, the journey itself would have transformed our technology, our understanding of the universe. The Riemann hypothesis, it's kind of like that. It spurred new areas of research, changed how we view numbers.
We've traveled from these basic building blocks of numbers to this mind-bending concept of the critical line, and it's all thanks to this unsolved problem, the Riemann hypothesis. Talk about dedication.
It shows you that math isn't just about finding the answer. It's the thrill of the chase, the pursuit of these elegant connections in the universe.
It makes you wonder, why are we so fascinated by finding patterns, especially in something that seems random like prime numbers?
Right. Is it just curiosity, or is there something deeper, this innate human need to find meaning and order in everything around us?
It's definitely something to ponder. Maybe next time you're looking at a number, any number, you'll stop and wonder if it has a secret life as a prime n. Thanks for joining us on this deep dive. We'll see you next time.